Hello everybody. Welcome to the Introduction to Reason as a Way of Knowing. This really is a brief introduction, and hopefully this will inspire you to think about looking into some of these ideas in further depth. Okay, before we start, here's a question, a test for you. Okay, and you should do well because it's a preschool test. A bunch of children were asked the following question. Which way is the bus traveling? In which direction is the bus traveling? Look carefully. Do you know the answer? It can only be either left or right. Think about it. Still don't know? Okay, pause the video now. Have a vote. Left or right? Okay, did you make a decision? All of the preschoolers answered right. Why? They all said, because you can't see the door. Very nice. If preschoolers can work out these sort of problems, that sort of implies to us that logic and reason are natural things that we're just born with. However, the evidence would suggest that that's not the case. Talk to anyone who works in a hospital emergency ward. They will tell you that maybe people aren't naturally born with the ability to reason. I want to suggest that it's definitely something we can learn and something we can grow in. There are 5 types of reasoning that we're going to look at in this video. This is just an introduction to get you to think about some of these important ideas. We're also going to be using some important words that you can see here. We are just not going to define them now, we'll define them as we go along. So let's start. Deductive reasoning means going from general rules to specific applications. It's sometimes called top-down logic. Here's an example. There's a general rule, all Australians are good swimmers. Excuse me. I am an Australian. Therefore, I must be a good swimmer. Unfortunately, this is not true. Here's a picture of me at the beach. I am not a good swimmer, so even though our logic here is correct, this is not a true conclusion because our initial assumption, all Australians are good swimmers, is not correct. Here's another example of deductive logic that's also not quite right. Now here, our logic is true. The argument is valid, but the statements are not real or true because Koodle, Fopsy and Canjet are just words I made up. They're not actual real things. Deductive logic is used a lot in mathematics because we start with general rules or axia, and these are always true, and we try to apply them to particular situations and particular problem-solving scenarios. But at each stage we need to assess the internal and external validity of the assumptions we made. Next we have inductive reasoning, and this is the opposite. It's moving from the specific examples to create a general rule or theory or principle. So while deductive was top-down, this is bottom-up. It's the basis of empiricism or scientific study or study from observation. Here's an example. I observed a lot of substances. They all expanded when they got hot. Therefore, here's my general theory. Things expand when they get hot. Now, a potential problem with this is illustrated in this classic example. European biologists observed a lot of swans, and they saw that all these swans were white. So they made a general rule, all swans are white. Problem is, they came to Australia, and they discovered black swans. So the general rule was blown out of the water by one single example that was different. Okay, so in order for inductive reasoning to be valid, you have to really test every single example, specific example, in the known universe. That's never possible, so we kind of make do with what we've got and consistently refine our theories. Here's, I think, a good cartoon that illustrates this. How can anyone prove no two snowflakes are alike? Look, stupid. I've examined over 800,000 specimens without a single duplication. If that ain't proof, what is? Could be a lucky coincidence. Most mathematics relies on deductive, but probability is inductive. For example, I spin this spinner 10 times and it landed on orange 6 times. So now I can suggest the probability of landing on orange is 60%, 0.6. Analogical reasoning is another type of reasoning where you compare two similar things and make inferences from those comparisons. There's Darren Lockyer. He is 183 centimeters tall and weighed 87 kilograms, his playing weight. He was a great rugby league player. I think he's overrated, but yeah, can't argue with stats. I am also 183 centimeters tall. I used to weigh 87 kilograms until quite recently. So that means I must also have been a great rugby league player. I'm pretty good at touch football. Okay. Penguins also seem to struggle with analogical reasoning. Okay, the next form of reasoning is hypothetico-deductive reasoning. For me, this is just a refinement of the inductive reasoning process. Basically, it's a new scientific method. We postulate a hypothesis and we test that hypothesis. If the test proves it right, then we accept the theory as true. If the test proves it wrong, we have to make a new theory, make a new hypothesis. So it's continually refining itself. So this type of reasoning is used a lot in quantum physics and Big Bang theory because cosmology, because we can't actually observe what is happening, or we can't observe what happened many years ago. It's also the type of reasoning used by the followers of the flying spaghetti monster, who hypothesized that his noodly appendage created the world, and they've tested this hypothesis, and since it's impossible to disprove it, it must be true. I don't believe that, but it's something we will discuss at a later date. The danger in this is the propensity for people to be closed-minded, and also erase the idea of confirmation bias. We want our hypothesis to be true, so sometimes we make it true, and we'll adjust our results to make it true and to suit what we want, which is summed up in this quote and this cartoon. Okay, the last type of reasoning is called creative reasoning or lateral thinking, which is looking for alternatives that are not immediately suggested by the other methods of reasoning. Often we'll try and dig a different hole by just digging the same hole deeper, using other forms of logic, and this really calls us to think outside the box. Speaking of thinking outside the box, I think this cartoon sums it up really well. And maybe if we thought more like children, sometimes we could accomplish more, and we could definitely accomplish more creative and more radical things. Okay, so that was our 5 ways of reasoning. Another popular suggestion is that reason is what separates us from the animals. They work on instinct, where we have the ability to assess our decisions and make appropriate conclusions. The size and structure of our brain seems to support this idea. However, I gotta say, the differences are much more significant than just the ability to reason. We have memory, we have language, we have more developed emotions, we do art, those things have just as significant as influence in separating us from the animals as a reason does. To finish off, I just got a few cartoons that you might want to have a look at and think about. So, in the arts and popular culture, reason is often a subject of humour, and the absence of reason can be funny. It's funny because it's true. Okay, lastly, that was my introduction to reason as a way of knowing. No, you can't see that says imagination down there. Okay, so there's our other 8 ways, or the 8 ways of knowing, and reason is just one of them. It works in concert with the others. In the rest of the lesson, or the rest of our sessions on reason, we're going to look at some of these important ideas, the importance of premises, what makes a good argument, and common logical fallacies. I hope you're looking forward to that. This should be an interesting and rewarding discussion. Bye for now.